Right, today in geometry, we are looking at 11.1 area of triangles and parallelograms. First, let's talk about what is area. So the area of a figure is the number of no overlapping unit squares needed to cover the figure. Area is measured in square units. A parallelogram is a four-sided shape formed by two pairs of parallel lines. Opposite sides are equal in length and opposite angles are equal in measure. The base of a parallelogram is the length of one side. The corresponding altitude is a segment perpendicular to the line containing that base, drawn from the side opposite the base. Height is the length of the altitude. Recall that altitude must be perpendicular to the base. Okay, so we're going to remember altitude must be perpendicular to the base. The area addition postulate: if a figure is composed of two or more parts that do not overlap each other, then the area of the figure is the sum of the area of the parts. A parallelogram with base B and height h has the same area as a rectangle with base B and height h. So we know the area of a rectangle is base times height. We know the area of a parallelogram is also base times height. If we take a parallelogram and cut it in half along a diagonal, we would have two congruent triangles. Therefore, the formula for the area of a triangle is the same as the formula for area of a parallelogram, but cut in half. And we know that the formula for area of a triangle is 1/2 base times height. In the case that the triangle is a right triangle, then the height and base would be the legs of the right triangle. So we do not use the hypotenuse in a right triangle when we are finding the area. Let's not use hypotenuse. If the triangle is an obtuse triangle, the altitude or the height could be outside of your triangle. And we'll look at some examples like that. So here we see if we have an acute triangle, if the triangle has an area of a square units, okay, a base of b units and a height of h units. So in this is our height. This is our base. Again, I know that's my height because it's perpendicular to my base. A right triangle, again, my height is a leg, my base is a leg. I don't use the hypotenuse. In an obtuse triangle, okay, again, the height, remember, must always be perpendicular to the base. So perpendicular, this is my base. Notice the height is outside of my triangle. So now we're going to talk about something called Heron's formula for the area of a triangle. This is probably something new. Okay? So what if I don't know height or base? Okay? So Heron's formula tells me that the area is equal to the square root of s times s minus a times s minus b times s minus c, where s is half the perimeter and a, b, and c are the sides of the triangle. So let's just look at some examples. So find the area. So number one, we have an obtuse triangle. My height is on the outside. I can tell that this is my height because it's marked perpendicular. So the area, it's a triangle, 1/2. The base of this triangle is 10. The height of this triangle is 12. So half of 10 is 5. 5 times 12 is 6. So I would say the area is 60. And then my units were centimeters, so I squared them. So 60 square centimeters. Number two, we can tell that this is a parallelogram. So the area of a parallelogram is just simply base times height. So the area here is 15 times 12. So when I multiply those together, I get 180. Again, my units were centimeters, so square centimeters. Number three, I have a right triangle. All I need are the two legs. That's what I have. So number three, the area of a triangle, 1/2. Base is 16. Height is 8. So half of 16 is 8. 8 times 8 is 64. So here my area is 64. Again, my units, so square centimeters. Number four, I have a parallelogram. Okay, this 18, I don't need that 18. That's extra information. Sometimes they will give you more information than what you need. So area of a parallelogram is just base times height. My base is 24. My height is 16. I know that 24 is the base because it is perpendicular to the 16. So multiply 24 times 16, and I get 384. This one did not give me any units, so I will write square units. All right, number 5, I have a triangle. I have all kinds of things labeled in this triangle. Again, I have more information than I need. I don't need the 32. I don't need the 28. The 24 I can tell is my height because it's perpendicular, and what it's perpendicular to is my base. So this is my base, this is my height. So area of a triangle, 1/2, my base, 36, times my height, 24. So when I multiply all of that together, I get that the area is equal to 432. Again, I would write square units because it didn't give me any units. Number 6, again, I have an obtuse triangle. I see that I have a height that's marked perpendicular to this side, so that means that this is my base, and this is my height. Okay. It also marked this perpendicular, but I don't know this side. Okay. And in an obtuse triangle, my height is always going to be outside of my triangle. So that's how I know that I use the 16 on the outside and the 18 as my base. So the area is 1/2, 18 times 16. So half of 18 is 9. 9 times 16. So I get the area is 144. Again, I would write square units. Number 7, 8, 5, and 10. Okay, I don't know what kind of triangle this is, right? I don't have any angles marked. I don't have a height. Okay, so this is where I would use Heron's formula because I have the 3 sides. It doesn't matter which side I call A, B, or C. Very first thing we want to do is find S. Okay, so remember in Heron's formula we said that S was equal to the perimeter cut in half. So half my perimeter. Perimeter, remember, just means add up the 3 sides. So 8 plus 5 plus 10. And then cut that in half. So here I get that my S is 11.5 on this problem. So then my area is equal to the square root of S, 11.5, times 11.5 minus all of my sides. So 11.5 minus 5. 11.5 minus 10. All that's underneath the radical. So I'll work this out. So here I have the square root, 11.5. So let's see, 11.5 minus 8 gets me 3.5. 11.5 minus 5 gets me 6.5. And 11.5 minus 10 gets me 1.5. Gonna now multiply all of that underneath my radical together, and when I do, I get 392.4375. I don't want to round here. I'm not going to round to the very end. Now I'm going to take the square root of that, and here I can round, so I'm going to say my area is approximately 19.8. Again, I would need to write square units. Number 8, I see that I have a parallelogram, right? These should be marked perpendicular. This is going to be a height or that. Okay, they're going to be the same. So I need to find that height first. I know that this is 10. Okay, that's 3 over there. That's 3 over here. So now first to find my height, I need to do Pythagorean theorem since I have a right triangle. So I would say 3 squared plus h squared equals 14 squared. So 9 plus h squared equals 196. Subtract 9 from both sides, so then I get h squared equals 187. Take the square root. I'm going to leave this as the square root of 187 because I don't want to round here, right? You don't round to the final answer, and my final answer is the area. So now the area of my parallelogram, the whole base is 10 plus 3, 13, times my height, which I just said was the square root of 187. Plug all of that in, and now I'm going to round and say my area is approximately 177.8, again, square units. Right, so now let's look at some word problems. It says the height of a parallelogram is 5 feet more than its base. Okay, so my height is my base plus 5. The area of the parallelogram is 204 square feet. So area equals 204. But remember that my area is base times height. So we want to find the base and the height. So I'm going to rewrite this, right, and plug in what I know. So instead of A, I know the area is 204, equals the base, which we're just going to call B, times the height, which we said was B plus 5. So now I want to go ahead and distribute. So I have 204 equals B squared plus 5B. I have a B squared and a B, so that means I want everything on the same side. So I'm going to move the 204 over. I get B squared plus 5B minus 204 equals 0. This is where I either need to factor or quadratic formula. I'm going to factor so we can work on factoring. I don't have to worry about grouping because I have a 1B, so I just know I'm going to have 2 sets of parentheses, a B and a B. So I'm looking for what can I multiply together to get negative 204, but add to get my middle number a positive 5. 17 times negative 12 gets me negative 204. 17 minus 12 gets me 5. So this would be B plus 17, B minus 12. And I'm just going to come up here. B plus 17, so that comes out opposite. So base is negative 17. B minus 12 comes out opposite. Base is 12. Now I have to figure out which one of these am I using. Remember that B stands for the base. I cannot have a negative base, right? That would not make sense. So I know that my base is going to be 12 feet. My height, remember up here we said the height was the base plus 5. So 12 plus 5, 17 feet. So there's my base and my height. We'll try another one like that on number 10, only with triangles. So it says the base of a triangle is 1/2 of its height. So my base equals 1/2 the height. The area of the triangle is 36 square millimeters. Find the base and the height. Again, I know my formula for area of a triangle is 1/2 base times height. So I'm just going to plug everything into this formula that I know. Instead of A, I'm going to put 36 equals 1/2 the base. The base is 1/2 the height. So times 1/2 the height times the height, which is H. So now I'm going to work this out. 36 equals, so 1/2 times 1/2 gets me 1/4. H times H gets me H squared. I'm trying to get H by itself. I need to get rid of the 1/4. So remember a fraction, the opposite is flip and multiply. So I'm going to multiply both sides by 4. So here I have 4 times 36, that's 144, equals H squared. I want to take the square root of both sides. So H equals, I put the square root in the problem, so 2 answers, positive, negative 12. Again, H stands for the height, so I just want the positive 12. So my height is 12 millimeters. My base, over here, remember, we said base was half the height. So 12 cut in half is 6. So my base is 6 millimeters. All right. Number 11. Find the area of the parallelogram PQRS with these vertices. So in order to find my base and my height, the very first thing I need to do, I can either do distance formula or I can graph them. So we're going to go ahead and graph. So we're going to plot these 4 points. So 1, 2. That's P. 4, 2. That's Q. 5, 5 is R. And 2, 5 is S. So here is the parallelogram that we're looking at. So I know that my formula for a parallelogram is base times height, right? So my base here, so that's a nice vertical line, or sorry, horizontal line, so I can just count how many spots from P to Q. So I want 1, 2, 3, so this is 3. my height, remember that my height has to be perpendicular. So I'm going to drop my height down perpendicular. So perpendicular to a horizontal line is a vertical line. And again, since it's vertical, I can just count the spaces. So 1, 2, 3. So my base and my height are both 3 here. So the area is my base, 3, times my height, 3. So the area is equal to 9 square units. Now let's do one like that with a triangle. So find the area of the triangle with these vertices. Again, I'm going to plot the points. So -3, -1. Me A. B is at 3, 6. C is at 9, -1. So I need to continue my graph out. 7, 8, 9, -1. So there's C. So I'm going to draw that triangle. Again, this is going to be my base down here. I can go ahead and count those spaces. So when we count all of these spaces, we get 12. I need to drop my height down. So from my vertex up here at B, perpendicular down. Now since that is a vertical line, I can count those spaces. So that's 7. So I have the formula area equals 1/2 my base, 12, times my height, 7. Half of 12 is 6. 6 times 7, 42 square units. So that's all there is to section 11.1, finding the area of triangles and parallelograms. Again, probably the only really new thing here was the Heron's formula.